Hello, my name is Kunjumon Vadakkan. I study the nervous system to understand how it operates. I have a conflict of interest to declare. In this presentation, I would like to explain how virtual items were studied in mathematics. Mathematics is an exact science, but if we look carefully, mathematics deals with negative numbers which do not exist. Our sensory systems cannot reach those negative numbers, yet we are studying those negative numbers. We started studying them around 6th century. From examples of mathematics, we can get some confidence to deal with the virtual first person inner sensations in neuroscience. We should be able to develop a certain methodology to deal with them, to understand where they are getting generated, so that we can have a grip on them. Before 6th century, life was very simple on earth. Everything was counted in numbers: 3 apples, 2 oranges, and everything was quite simple. But later on, we invented the 2-dimensional graphs. That is, we have y-axis, and then we have x-axis, and we plotted all the positive numbers on this side. On the right side, and here again positive numbers. So everything on this side we can perceive with our sensory systems, because everything is real and we can have real access towards that. Whereas on this side, everything is negative. Negative 2, 3, 4, 5, and negative 6. And here as well. So if you take this quadrant, we have to plot, it's in y-axis or -1. So this point will be -3 plus 3. And we do not have any access towards the -3. That's a significant amount of progress have been made in mathematics, and the applications are there in physics, chemistry, and including in biology. If you make a plot here, the 1/4 is real and the 3/4 is virtual. If you also bring the third dimension into the picture, let's imagine the positive aspect of the z-axis on this side of the board, and the negative z is on the other side of the board. Then we have a 3-coordinate system, and in this system only 1/8 are real and 7/8 are virtual. We do not have any access towards them, but we are using them very well. We are comfortable in navigating in that negative space. So this is a clear example how mathematics have progressed. We were comfortable in dealing with the negative numbers towards which our sensory systems have no access. In the same way, the formation of the first person inner sensations, we have to find a method to get an access towards it. If you look another example, let's say there is a line here, there is another line here, there is a function here. You may also draw a plane here, a plane. So we have 1, 2, 3, 4. I can also draw another another line. So we have 1, 2, 3 lines, one function and one plane. So all these equations have a common solution at this point. Now, in the same way, we have lot of findings. So if you look carefully here, we have access only to the functions or the equations in this quadrant. We can access only this part. This part is not accessible to us. And this can be compared to the third person observed findings of the nervous system, and this side can be compared to the formation of first person virtual inner sensations. So we have large number of findings from the nervous system that can be sensed by our nervous system. We have to use all of these findings from various levels, and we should put the constraints, and from all these information available, we should find a unique solution that we can reach. So this point is within our reach. So we can reach at that point, and from that point the virtual nature of the extension of all the equations occurs. So now once we know the solution, now we can extrapolate these equations towards the virtual area. So in a similar way, we should put all the findings from various levels of the nervous system that are being studied by different faculties of brain sciences, and we should synthesize testable hypotheses. If such hypotheses are theoretically feasible, then we should make predictions that can be made by that hypothesis and go and test those predictions. Look at the circuitries of remote species for comparable circuitries. Examine whether it can operate in unison with synaptically mediated nervous system operations, and then we should be in a great position to replicate the mechanism in engineered systems outside the nervous system. So that should be the aim at this point of time. It's not easy, it's difficult, especially at the beginning stage, but synthesizing hypothesis should be the priority, without which we will have difficulties in dealing with the virtual inner sensations. And in the case of the mathematics, I explained the examples here. Similarly, in the case of physics, physicists, they deal with virtual items all the time. They are very comfortable in dealing with that because they have an exact science there which was developed systematically, step by step. So in the case of the nervous system, we should put all our efforts at this point of time to build testable hypotheses. I hope that you understood the examples that I explained from mathematics here, how we were successful in dealing with virtual numbers, and therefore we should put all our efforts at this point to take these examples and generate hypotheses in neuroscience. And thank you for watching this video. If you have any questions, please feel free to ask me below this video or email me. I will be happy to answer them as much as I can. Thank you for watching and have a great day.